if we have data of consumers' willingness to pay, we can then estimate demand function from the willingness to pay data. Okay, here's one example. Suppose I have data of willingness to pay for COVID-19 vaccines. And this data is actually a contingent valuation study by researchers in China. So our task now is to estimate a demand function for COVID-19 vaccine in China. And then using the demand function we estimate, we want to calculate the consumer surplus. Okay, the first step is to estimate, obtain the willingness to pay data, and here we already have. We can implement a contingent valuation studies to survey these survey consumers, solicit consumers' willingness to pay for the COVID-19 vaccine. Then step 2, sort the WTP data in descending order. So I'm already sorting this in descending order. Okay, so for example, you can sort it in ascending, descending, but we need descending. Step 3, extract unique values of this WTP. So by looking at the WTP data, we know that okay, quite a few people are willing to pay, say, 325 yen actually, Chinese dollar, and there are a number of them willing to pay 275, so on and so forth. Okay, let's extract unique value. To do so, I already extract here, but I'm going to illustrate how to do. So filter, advanced. So the input data is set from here to here. Okay, that's the input. Then we want to extract unit record. We want to copy to a particular location. Let's choose copy to this point. And okay, so there you go. So we extract the unique values within this WTP data. Okay, I want to calculate. Then I want to calculate the frequency. So I'm going to use the frequency function. So data is from A2 to A1269, and the bins is from C3 to C3 to C10. That's the unique value we have just extracted, and we find that there are 170 interviewees respond that they are willing to pay $325 yen for the COVID vaccine. Similarly, this category is 33, 50, 157, 108, 179, 329, 306. Altogether, there are 1,268 interviewees, and let's calculate the percentage. Okay, so in the total number of interviewees who are willing to pay $325 yen for the COVID-19 vaccine account for roughly 8.4% of the total number of interviewed persons. And this should sum up 1 equal to 1. Okay, so that's step 4. Then we want to calculate empirical CDF, which is empirical CDF of this willingness to pay, which is probability or probability that willingness to pay is less than the particular, say less than or equal to 325 or 275, so on and so forth. So we can calculate this. Sum up, let's sum of, okay, for example, say I want to calculate probability of willingness to pay less than 325. So which is the share of people who report they are willing to pay 275, 225, 175, 137, 112, 87.5, 62.5. Okay, so sum all this share up, we get 0.9156. Similarly, for this less than share of willingness to pay, which is less than 275, is sum of this, so on and so forth. Okay, then calculate 1 minus FP. Okay, 1 minus 0.9156. Okay, these are the share of people. If we set, for example, we set the price of the COVID-19 vaccine to be $325, then within the population, there will be 8.4385% of people will purchase the vaccines. So the quantity of vaccines, if the price is set at $325, would be share of this 8.43% times the total population, and let me set it to be 1 billion, which is roughly which is close or approximate the eligible adults populations in China, times 2. And you know that I'm using $1 to fix the difference, and times 2 because each adults is required to take 2 vaccines. So it's 0.16877 billions. Similarly for this, up until this. Okay. So now we construct quantity. That's step 6. So we have price data here, quantity data. And what we can do is we can regress quantity against the price. You estimate demand function using OLS. So I'm going to show you how to do estimation, OLS estimation in Excel. So click the data and using data analysis, choose the regression function. And dependent variable with quantity. Independent variable will be price. And I'm going to estimate only a linear demand function. And my selection includes labels. I'm going to output the results into a new worksheet. So that's the result. That's the regression result, and that's the same as what we have here. So here the demand function I estimate is Q is equal to 1.92 minus 0.00635 times price. So that's demand function. Okay. So that's a demand function here. Then from demand function, I want to calculate inverse demand function. Okay. So basically, what I'm doing is move this term to this side, this term to this side. So I get 0.00635 P is equal to 1.92 minus Q. Divide both sides by 0.00635. So I get the inverse demand function of this. Okay, so the intercept of this inverse demand function is just 1.92 divided by 0.00635, and the slope will be 1 over negative 1 over negative 0.00635. Okay, so it's 157. Then I'm going to plot this inverse demand function into a diagram like this. Okay, so all I want to do is I'm going to say using if Q is 0, what's the associate price? Q is equal to 0.2, what's the associate price? So using the inverse demand function would be 302 minus 157.493 times 0.02, so on and so forth. I got this data. I can draw, insert, scatter plot of this, and that's what I already draw here. Okay. Then now look at the inverse demand function, and consumer surplus is the area of this triangle. So now it's easy to calculate. It's the area of this one, the density of this side times the density of this side divided by 2. Okay. So consumer surplus would be 1/2 times length this side, which is 3. So we need to work out this vertical intercept. When quantity is 0, the vertical intercept will be like 302. Okay, and we also need to work out this point. That's the corresponding P will be 0, and we can work out the corresponding Q. Q is 302 divided by 157. Okay, so using it's roughly 1.923. So this is 1.923 something. So using this information, we calculate the size of the triangles, which is 290 billion yen, and convert into Australian dollars approximately divided by 5, let's say. So 58 billion Australian dollars. Okay, this is one method of estimating demand function and computing the consumer surplus from a willingness to pay data.